we examined why we need to use frequency domain in this chapter, and what we are going to examine next is the Kirchhoff Laws equations, what's going to be in frequency domain, definition relation of the elements, what's going to be in frequency domain, and the new terminology, impedance and admittance. Why we are examining this? Because in the classical circuit analysis, we know that we've got to write NE equations. NE of these equations are related to Kirchhoff current laws and voltage laws. The other NE equations related with the elements definition relations. So we are examining those in frequency domain. The first video is related with the Kirchhoff laws in frequency domain, so this is this video. Let's go inside. Just remember what Kirchhoff voltage law equation is. Algebraic sum of the elements voltages within a loop is equal to 0. Algebraic sum of the elements currents for a node is equal to 0. So Kirchhoff voltage law equations in time domain, you can write it as this. For a loop, if there are p elements in that loop, these elements voltages summation is equal to 0. Algebraic summation, that means there's going to be sign in front of those voltages. So let's outline what we are saying here. Kirchhoff laws are true for the phasors. We are going to end up with this. So in frequency domain, we are going to write Kirchhoff current laws and voltage laws. These laws equations are going to have the elements, voltages and currents phasors. Aim is to find a particular solution while the sources are AC signals. So assume that this AC signal is this. This is source signal. So we know that if the source is sinusoidal, and if we are going to find out the particular solution only, this particular solution is going to be a sinusoidal function. We know that we can write the sinusoidal function in terms of the phasors. So these sinusoidal functions that we are going to find is going to have 3 parameters. We need to calculate those 3 parameters. We already know that one of the parameters for these sinusoidal functions is the same as the source frequency. That is frequency. That means particular solution of elements current and voltages is going to be sinusoidal function. This sinusoidal function's frequency is the same as the source frequency. Therefore, we do not need to calculate that frequency. What is left? Amplitude and phases are needed to be calculated. So we've got to calculate the amplitude and the phase. Phase is angle. So phasors, don't confuse with phase and phasor. Phase is the angle. Phasor is the new terminology we introduced and we examined it in the previous video. Phasors include these 2 amplitude and phase parameters in it. So we are going to calculate 2 parameters. These parameters are the ones that we have in our phasors. So that means we can find, if you find the phasors, so we can solve it. So let's transfer that information to here now. We wrote the Kirchhoff voltage law equations in time domain. So since we know all the elements current and voltages is going to be the sinusoidal functions, we can write this sinusoidal function is this form. We already examined that. This form includes that VI is the phasor of the element voltage. Phasor multiplied e to the power j omega t, real part of it gives you the sinusoidal function in time domain. So if you replace this sinusoidal function with this one, with this new representation, you end up with this. So if we take that real part, which is common for all the summed terms here, if you take that real part outside, you end up with this. You can take that aj omega t, which is common in all those terms as well. You take this out, you end up with this. This tells us what? This tells us that Kirchhoff voltage law equations are true for the element voltage phasors, because that VI's are the voltage phasors. If we do the similar examination for the Kirchhoff current law equations, we end up with this. And the total result tells us Kirchhoff voltage law are true for the elements voltage phasors. Kirchhoff current law equations are true for the elements current phasors. So that is the end of this video. Conclusion is that Kirchhoff laws are true for the phasors in frequency domain.